Understanding El Nino and La Nina phenomena and their implication on India / understanding El Nino and La Nina phenomena and their implication on India / names 1. Discuss the mechanism of El Nino and establish its effect on the Indian agriculture in general. 200 words. 2. In view of El Nino, what immediate and long-term steps can be taken by government at the state and local levels? 200 words. 3. Better management of the public distribution system (PBS) can mitigate the impact of El Nino on the Indian economy. Elucidate. 200 words. Introduction. Monsoon is a familiar though a little known climatic phenomenon in India. From agriculture to economic policies to disaster management, a lot depends on a monsoon. A monsoon is a recurrent event. It repeats after a certain frequency of time, a year in our case. But it may not be uniform in every period year. There are a lot of factors which affect its duration and intensity over India. A monsoon is basically the result of the flow of moisture-laden winds because of the variation of temperature across the Indian Ocean. There are a number of climatic phenomena which affect it, namely the Indian Ocean dipole, El Nino, La Nina, equatorial Indian Ocean oscillation, EQUINO, etc. These phenomena affect the temperature distribution over the oceans and thus affecting the direction and intensity of flow of the moisture-laden winds. There have been recent reports that El Nino may disturb the Indian monsoon and play badly with Indian agriculture. This brings us to the discussion of the concepts of El Nino and La Nina. In what follows, we will look at their origin, mechanism, impact and mitigation strategies. We need not go into trivial details but only understand them from exam point of view. Origin. El Nino and La Nina, opposite phases of what is known as the El Nino Southern Oscillation (ENSO) cycle. The ENSO cycle is a scientific term that describes the fluctuations in temperature between the ocean and atmosphere in the east-central equatorial Pacific, the area between South America and Australia near the equator. Look at the diagram. West-east. La Nina is sometimes referred to as the cold phase of ENSO and El Nino as the warm phase of ENSO. These deviations from normal surface temperatures can have large-scale impacts not only on ocean processes, but also on global weather and climate, including India. Mechanism. Now, it is important to understand how these phenomena affect a monsoon system. To know this, we must first know the pressure and temperature distribution in the region before their onset. We are assuming here that you are a little bit familiar with the phenomenon of monsoon. For a normal monsoon season, the pressure distribution is as such. The Peruvian coast has relatively high pressure than the areas near North Australia and Southeast Asia. The Indian Ocean is slightly warmer than the adjoining oceans. West Pacific SEE diagram, and thus the pressure is low relatively due to the warm seas. This is why the moisture-laden winds move from near the West Pacific to the Indian Ocean and from there on to the lands. The pressure on heated Indian land is much lower than that on the Indian Ocean. This facilitates the movement of monsoon winds from the sea to the Indian land without any significant diversion. But if for some reason this normal distribution is affected, then there is a change in the way trade winds or monsoon winds would blow. However, the following is the pressure and temperature distribution in an El Nino situation. This is because of the following reasons and its effects. Off the coast of Peru, in eastern Pacific and central Pacific, there is normally cool surface water because of the cold Peruvian current. But El Nino makes it go warm. When the water becomes warm, the trade winds, which otherwise flow from east to west, either reverse their direction or get lost. Due to this warm water, the air gets up and surface air pressure above eastern Pacific gets down. On the other hand, the waters cool off in western Pacific and off Asia. This leads to rise in surface pressure over the Indian Ocean, Indonesia, and Australia. Now, as the pressure over the Peruvian coast reduces because of the warm seawater, the flow of moisture-laden winds is directed to the Peruvian coasts from the western Pacific. The areas near North Australia and Southeast Asia, refer to the diagrams above. Hence, the moisture-laden winds that should have moved towards the Indian coast now move towards the Peruvian coast. The warm water causes lots of clouds getting formed in that area, causing heavy rains in Peruvian desert during El Nino years. This robs the Indian subcontinent of its share in monsoon rains. The greater the temperature and pressure difference, the greater would be the shortage in the rainfall in India. La Nina Anti-El Nino, or simply a cold event, is the cooling of water in the eastern Pacific Ocean. The following happens in La Nina. The water in eastern Pacific, which is otherwise cool, gets colder than normal. There is no reversal of the trade winds, but it causes strong high pressure over the eastern equatorial Pacific. On the other hand, low pressure is caused over western Pacific and off Asia. This has so far caused the following major effects: drought in Ecuador and Peru, low temperature, high pressure in eastern Pacific, heavy floods in Australia, high temperature in western Pacific, Indian Ocean, off-coast Somalia, and good rains in India. Drought in East Africa. For India, the El Nino is often the cause for concern because of its adverse impact on the southwest monsoon. This happened in 2009. A La Nina, on the other hand, is often beneficial for a monsoon, especially in the latter half. The La Nina that appeared in the Pacific in 2010 probably helped 2010's southwest monsoon end on a favorable note. However, it also contributed to the deluge in Australia, which resulted in one of that country's worst natural disasters, with large parts of Queensland either underwater from floods of unusual proportion or being battered by tropical cyclones. Periodicity. This distortion is pressure and temperature recurs every 4 to 5 years, but it may not happen exactly after 4 to 5 years, or it may not happen at all. Its periodicity is thus quite uncertain. El Nino and La Nina episodes typically last 9 to 12 months, but some prolonged events may last 4 years. They often begin to form between June and August, reach peak strength between December and April, and then decay between May and July of the following year. While their periodicity can be quite irregular, El Nino and La Nina events occur about every 3 to 5 years. Typically, El Nino occurs more frequently than La Nina. Correlation of El Nino, La Nina, and drought in the Indian landscape. Looking at the relation between El Nino and Indian droughts since 1950, it is observed that India faced 13 droughts, and 10 of these were in El Nino years and 1 in a La Nina year. This indicates there may not be a one-to-one correspondence between El Nino and Indian droughts. The paper by Ashok Gulati and Shita Singh of Indian Council for Research on International Economic Relations (ICRI) has stated, overall, the analysis proves that since the 1980s, only El Nino years converted into droughts for our country. However, a La Nina year does not guarantee better than normal rains, and similarly an El Nino year does not always translate into below normal rains, it said. The paper also stated that as El Nino phenomenon may hit in the second half of a monsoon season in 2014, factors such as favorable water reservoir levels and high stocks of grains with the government may offer relief to farmers and consumers. Impact of El Nino. Normal or high rainfall in eastern/central Pacific, drought or scant rainfall in western Pacific/Asia. This leads to a lot of undesirable circumstances. When the rainfall for a monsoon season of June to September for the country as a whole is within 10% of its long period average, it is categorized as a normal monsoon. When a monsoon rainfall deficiency exceeds 10%, it is categorized as an all-India drought year. IMD. In India, almost 50% of the area under cultivation is rain-fed. Indian agriculture is thus heavily dependent on the climate of India. A favorable southwest summer monsoon is critical in securing water for irrigating Indian crops. So, the significant reduction in total rainfall results in a drought-like situation. Drought in India has resulted in tens of millions of deaths over the course of the 18th, 19th, and 20th centuries. In some parts of India, the failure of a monsoons result in water shortages, resulting in below-average crop yields. This is particularly true of major drought-prone regions such as southern and eastern Maharashtra, northern Karnataka, Andhra Pradesh, Odisha, Gujarat, and Rajasthan. A lot of farmers suicide because they are not able to repay the loan they had taken for growing the crop. Shortages in food supply then result in spiking food prices all across the country, pushing inflation up. High food inflation leads into other sectors too, such as food processing sector. This pushes the RBI and the government to adopt a more cautious approach to monetary and fiscal policy respectively. The tighter monetary policy to tame food inflation may affect the economic growth rate of the nation. Besides, lower agricultural production already lowered the GDP of the nation, dealing the double blow. If the drought is severe, It would dry up major sources of fresh water, leading to a water crisis-like situation. The groundwater level will also go down. This would not only affect supply of drinking water, but also supplies of water into canals and hand pumps for agricultural irrigation. Weak monsoons also result in lesser power generation from hydropower dams, thus leading to even lesser electricity for irrigation purposes. This further reduces the crop yield. Another important source of income for the farmers is livestock and the fisheries. Both are affected severely by the drought. What is the way out? Near-term solutions: the government must expand the farm insurance cover and advise banks and financial institutions to settle crop insurance claims in the drought-hit areas without delay. Otherwise, we will be seeing a lot of farmer suicides. High-quality seeds of alternative crops must be distributed among farmers in the drought-affected areas. The government must realistically assess the ground-level situation in order to estimate the shortfall of oilseeds and pulses and help traders with market intelligence. It should also bring down the cereals inflation by liquidating the extra stock it was holding, which is way above the buffer requirement. Scrapping the APMC Act and allowing free flow of agriculture goods among the states. This would help bridge the mismatch of demand and supply of goods, which is the underlying factor contributing inflation. The distribution of pulses through public channels at subsidized prices, as was done in 2008, to all the households is needed. The government should also provide a fuel subsidy that enables farmers to provide supplementary/alternative irrigation through pump sets in the drought and efficient rainfall areas to protect the standing crops. Long-term solutions: developing drought-free crop varieties and distributing its subsidized seeds to the farmers. It is a part of National Action Plan on Climate Change in Agriculture. Strengthening the crop insurance regime in India by making the drought identification, drought and crop loss claim and receipt of relief efficient, quick and transparent. Achieving financial inclusion so that the farmers are able to take loans from more credible, accommodative and benevolent sources such as regional rural banks or RBs. This would help them tackle distress-like situations. Using low water use technologies like drip and sprinkler irrigation. Moving away from water-intensive crops to less water-consuming crops. The MSP regime in India has to provide more remuneration for other less water-consuming crops. As in India, about 80% of the water is used for agricultural purposes, a lot of which is used by crops such as rice. Strengthening community watershed management and development. This can be done by protecting and conserving local water sources like ponds, lakes, etc. Several government schemes like IMG&REGA, Integrated Watershed Development Program, etc. can be utilized in this. Developing early warning systems and alerting the farm